So as usual, we're going to do a bit of real quick review, catch up on where we've been, and give you an opportunity to ask any kind of questions or follow-ups from last time. So here's where we're at. We're trying to come up with an analysis of cognition. We're trying to come up with a basic process in terms of which all other cognitive processes can be analyzed. Why did we decide to try to do this? It's a rather difficult task, right? Because having an analysis of a phenomenon is much harder than coming up with a true theory. So last time we saw some theories of categorization that we thought, yeah, that might even be true. Like that might be how we do categorization, but it failed the test of trying to come up with an analysis because an analysis has to break down into simple parts. And we found at the core of some of these theories of categorization, non-simple parts. That is, little moving parts in the theory that involved intelligence. So we've set this rather high bar for ourselves, trying to come up with a theory of cognition that it should be an analysis. So right now we're doing categorization. We'll continue to do categorization today, and I believe there's one more session on categorization on Thursday, and then we'll do one on memory, and then we'll spend some time on problem solving. The problem-solving section, just by way of preview, is not going to be quite as pessimistic as the categorization and memory sections, where basically I'm just going to continue to give you a whole bunch of examples of ideas from history and show that they fail the analysis test, which is a bit depressing. Like you kind of hope to learn things that are true and good and all that stuff. We're getting there. I promise that once we get to problem solving, it won't be a complete catastrophe. It will just be an open question, open questions. That's where we're going. Okay, so we talked a little bit about the problem of categorization. We distinguished categories which have something that bind them together from classes or sets, which are just jumbles or collections of things. And of course, we said our target was understanding categories, how we come up with them, how we include things or exclude things from categories, and that kind of thing. And I tried to make this quick argument for you, this motivation for the idea that maybe categorization is the thing that we're looking for in terms of a basic cognitive process. And that argument was, like a lot of the arguments I'm going to give you, kind of argument sketches. This argument was basically, we tried to imagine our worlds without categorization and found that it would be a nightmarish hellscape. It would be like being on too much acid or something like that. Just like everything that you encounter would be a unique individual. You'd have no ability to infer from past experience to future experience. You'd be unable to communicate your experience. You'd just be in a sensory, like, whirlwind, like this weird fellow here. So the complete catastrophe of not having categorization suggests to me, and I suggest it to you, that maybe this makes this a basic cognitive process. That is, it's at least necessary for cognition, and maybe then we could figure out a way to show that it's sufficient, and that would be evidence that it's the basic cognitive process in terms of which we're going to analyze cognition. That's just kind of a quick sketch, quick motivation. You don't need to prove that categorization is the basic cognitive process before you start. You just have to start and see if it works out. So. And we looked at a couple of theories of categorization. Very importantly, we looked at the resemblance theory. The resemblance theory, defended by Smith in the reading from last week, tried to understand categorization in terms of resemblance or similarity between objects. So we say, and I try to pitch this to you as one of the most intuitive ways that you could think about categorization, in some sense, the common sense way of thinking about categorization. It's just obvious, right? It's just obvious that the way you group things together is by noticing their similarities and then putting things that are similar together into a group. But unfortunately, obviousness is very often the enemy of reason, because what's obvious to you is not necessarily what's true. And in this case, what we found was that it turns out to be really hard to formalize our ability to judge that things are similar. And in some sense, our ability to judge that things are similar depends on our ability to categorize, and our ability to categorize depends on our ability to judge things that are similar. So we really didn't get under the hood of cognition, as it were. We really didn't get to the core of the thing using resemblance theory, because you need intelligence to judge that things are similar. right? We talked about Goodman's problem, where two things share an infinite number of similarities. I got an interesting question during the break about whether there are actually an infinite number of differences between two things, which I could not properly answer, worth thinking about. But all this argument really needs, all Goodman's argument needs, is sort of that there are an infinite number of similarities between two things. And in addition to coming up with an analysis of cognition, one of the things that we should hold ourselves to is coming up with a story of cognition that you could fit in our tiny primate-sized brains, right? We're basically running around with slightly souped-up chimpanzee brains. And if you come up with an algorithm for cognition that needs kind of like enormous astronomical-sized computational power, then it's clear that's not how we do it, at least, right? So it would be nice to not only have an analysis of cognition, but an analysis of cognition that you can imagine running on our brains. So if your analysis involves an infinite list of things, going through an infinite list of things, that's bad, right? Okay. Okay, so within resemblance theory, we saw two attempts to formalize similarity, right? So under the umbrella of resemblance theory, we looked at two attempts to formalize similarity that would help make this thing precise. We saw the geometric account of similarity and saw a few problems with it, specifically that people don't act like this. So this way of representing similarity doesn't capture how people actually do it. For example, we say that apples are more like apples than apricots are like apricots. We do things like say that apples are more, or pears are more similar to apples than apples are to pears, right? These very weird, so that's a violation of the symmetry condition and the minimality condition. So we gave up on this. We said, no, okay, probably geometric account's not going to be the right formal account. And then we briefly looked at this thing. So Smith presents this in the reading. It's originally from Tversky in the 70s, a formal representation of similarity. And this solves some of the problems with the geometric account, right? It tells that this thing predicts that people will make these weird judgments. Apples are more similar to themselves than apricots to themselves, and the violation of the symmetry account. So this was progress, right? So when you're doing science, what you want to do is look at the problems of the theory that came before you and try to come up with a theory that solves them. So this was a genuine step forward in the account of similarity. But that's not to say that it's the final story, of course, because we found some deep, deep problems that I mentioned just a minute ago with this account. Specifically, I mean, the most important ones for our purposes are these coefficients that go into it. So how much weight you put on each of these factors and how salient each of the properties within those things are. And we tried to think about writing a computer program that would judge the salience of things and how fiendishly difficult that would be, right? Salience is not a thing that stays put. It's not a thing that you can measure in the world, as far as we can tell. Salience is a context-sensitive question that you need quite a bit of intelligence to figure out. And one of the things that really intelligent people do is home in on what's important, rather than just going through the data in a kind of insensitive way. So A, B, and C, these coefficients, and F, the salience of the properties, are little homunculi. Remember the homuncular fallacy? The homuncular fallacy is positing the thing that you're trying to explain, right? So you're trying to explain vision in terms of vision. Here we're trying to explain intelligence in terms of intelligence. And this is, again, not to say that this is false. This could be true. This could be a true representation of how similarity works in the human mind. It's just not an analysis, which is what we're trying to do, which is what you need if you're going to take the next step and actually build a mind. If you're going to try to build AI, these homunculi are no good. These are just they are, as it were, kicking the can down the road. You're saying, well, here I've done my work, and now somebody much cleverer than me has to figure out these really hard bits. You're just kind of compressing the difficulties of the question into a coefficient and sort of shoving it off to the side. So if our goal is actually to understand the mind deeply enough that we could build one, that's not going to do. Yeah? Okay. And really quickly, we saw Smith kind of push back. So we saw a bunch of critiques of this from Rips And then we saw Smith push back with his attempt to distinguish similarity-based and rule-based, but we found this to be a bit unstable, a bit unclear, and I believe that's where we left off. Okay. Quick comments, questions about any of that stuff? Okay. You're allowed to ask questions after this too, so you can ask retroactive questions if you want. Okay, let's get into new stuff then. So, today we're going to be talking about concepts, which is pretty deeply related to categorization. They're pretty much the same topic. If you have a concept, one of the things that a concept does for you is allow you to categorize things. And if you're categorizing, probably that means that you have a concept that lets you do the categorization, right? So these are practically the same topic. They get slightly different treatment in the literature, but we're just kind of continuing on with the same thing. So, right, so like we're still under categorization, but now we're suggesting that instead of similarity, there's a kind of conceptual structure that does the categorizing for us. So a concept is not necessarily a similarity judgment. It could be an idea or something like that. And what we're going to start from is, once again, kind of a common sense picture. And a lot of the time when people say common sense, what they mean is what Aristotle said. Aristotle's gotten so deep into global culture that he gets confused with common sense quite a bit. So this is Aristotle. When we're talking about the classical theory of concept, we're talking about classical in the like ancient Greek sense of classical. And here's what Aristotle says. A concept is a mental definition. And he means definition in a very specific sense, a very strong sense of definition. He says, a real definition gives you the necessary and sufficient conditions for an object to be an instance of the concept, or to be in the category, as we might say, right? If you crack open a dictionary, what you're going to find are not things that satisfy this notion of a definition. What you're going to find in a dictionary are useful hints that an intelligent person could use to figure out how other intelligent people are using a word, right? Just by reading a dictionary definition, you don't get one of these. Just to quickly clarify, so somebody tell me what a necessary condition is. Somebody who's done philosophy knows this. Come on, philosophers, hey. Right, it needs to be present for a thing to happen. And a sufficient condition is something that's enough, right? So, so think about, when I'm thinking about necessary sufficient conditions, I always think about fire and oxygen, right? So fire is or oxygen is a necessary condition for fire. No oxygen, no fire, right? Fortunately, oxygen is not a sufficient condition for fire. If oxygen was a sufficient condition for fire, we'd all be on fire right now, and that would be terrible for us, right? Just having oxygen isn't enough to have a fire going. However, it's a necessary condition. So necessary conditions are things without which you're not a thing, and sufficient conditions are things such that if you've got a thing, then you are it. So the classical theory of concepts is supposed to be a list of necessary conditions, right? Each of which is necessary. So you say it needs this thing and that thing and the other, and all together, jointly, they are sufficient. Yeah? Okay, so just go through a few properties of the classical theory. So the meaning of a concept can be captured by a conjunctive list of features. I'm going to use a square as my example for I think I have 6 properties of the classical theory to go through. I'm going to use a square because the classical theory of concepts really works nicely for mathematical, geometric, logical, formal properties, right? This theory actually describes very nicely how we do things in purely formal languages. So a square is a plane figure, and it has 4 equal straight sides, and it has 4 right angles, right? So notice the ands in there, and one thing, and another thing, and another. So conjunction is just an and statement. A conjunct is just one thing and another thing. So the definition of this is the definition of a square. It's just this and this and this, yeah? And if anything has all three of those properties, I hope you agree, it's a square. Anybody think of something that has those properties and isn't a square? No, hopefully not. Hopefully geometers have got the square concept pretty much nailed down at this point in history. And if anything fails to have one of those properties, it's not a square, right? They're all necessary, and altogether they're sufficient for being a square. Good. So it's a conjunctive list of features, this and this and this. The features are primitive or atomic, just in the sense that you can separate them apart from each other, right? So being four-sided is one feature. You can have being all right angles is another feature. You can have something that's four-sided without having right angles. You can have something with right angles that's not four-sided, right? Make sense? Okay. Each feature is individually necessary and jointly sufficient. And so anything with all of the atomic features is a square. Anything that lacks even one of them is not a square. And important going forward, anything that what is or what isn't a member, what is or what is not a member is clearly defined. So in geometry, for example, something's a square or it isn't. There's no notion of something being more a square than some other square. Like, this is a square, but this is a much better square, right? That's just not a concept that we have in geometry. We'll see this is one of the points at which the classical theory of concepts doesn't do the job that we want, because people do make this kind of judgment where you say, well, this is more bird-like than that, right? So the classical theory of concepts predicts perfectly crisp categorization. Perfectly crisp. You're either in the category or you're out. And all members of the concepts category are equally representative. That is, all squares are equal, equally squarish. No? So far, so good. I mean, hopefully you're not learning a whole lot right now. Hopefully what's happening is I'm just saying, I'm explicitly articulating what you kind of already know. I'm putting words on things that you've got in your head already. One of the reasons why we're doing this is to critique it as a theory of cognition, right? So getting common sense explicit is the first step to getting out from under it as a kind of mental trap. And finally, when organized in a hierarchy, subordinate definitions include definitions of the superordinate. That sounds fancy, but it's not. Here's all that means. If you define large square, you have to include all of the features of square and also the features of large. If you define large blue square, you need all the features of large square, which needs all the features of square. Yeah? So we just if you have a nested definitions, the outermost definition must include all of the features of the innermost definition. If you've got part of the definition of a mammal is that it's alive, then you can say any of the properties of alive things apply to mammals, right? And so that's basically the classical theory of concepts. It's Aristotle's theory of concepts. It's the theory of concepts that philosophers have been working with for a really long time. We got into real trouble like arguing about things like justice and knowledge on these terms, because if you can come up with one counterexample, you've ruined the definition according to the classical theory. It's a nice theory though, because what it gives you is the following. It gives you classical logic. So here's a good old Aristotelian syllogism. All dogs are mammals. Henry is a dog. There's Henry. And therefore Henry's a mammal. Now, notice how the properties of concepts that we just described are necessary to get this going, right? So for example, if the category of mammal is kind of fuzzy, I know mammals are fuzzy, but you know what I mean. The category itself has kind of blurry edges, and maybe not all mammals are equally mammalian, then this inference isn't as certain, right? So if most dog, or the definition of dog, right? So maybe only 95% of dogs are mammals. Now, how do you feel about this deduction? You shouldn't, like if we believe Aristotle, if we believe that Aristotle just told us how concepts work, then this is a deductive argument such that if those premises are true, the conclusion is guaranteed to be true, like logically guaranteed to be true. But if our concepts are not the classical notion, then that's not a completely, you can't be completely confident based on the premises that that conclusion is true. So just by way of historical note, what the classical theory of concepts did for us, it had a crucial place in how logic worked right up until the late 19th century or something like that. Okay, so there we are. That's the classical concept, classical notion of concepts. It was, and still is, kind of common sense for most people most of the time. It's got a bunch of advantages. It's a good theory in a lot of ways. For example, it avoids all of the problems of the resemblance theory. Like, what were some of the problems with resemblance theory? Well, we just talked about how you need intelligence, right, to figure out how important features are. To make resemblance theory work under the Tversky model of resemblance, you needed to be smart enough to figure out which are the important features. Classical theory, not at all. Yeah?
Ripps also showed the dissociation between similarity and categorization.
Right. So good. So Ripps shows that that similarity comes apart from categorization. That's not true here because we're not relying on similarity anymore. We're relying on this conjunctive list of features that are individually necessary and jointly sufficient. Remember that stuff from Nelson Goodman about how things have an infinitely long list of similarities? Well, you don't have to worry about that on Aristotle's account of concepts, do you? That's not a problem for Aristotle. Aristotle says, look, here are the 3 properties of squares. If you have those properties, it's a square. If you don't, you're not. The end. There's none of this messing around with infinite lists of things. So great. Good, Aristotle solved it. So yeah, so it solves the problem of identifying the relevant properties. It tells us how we do things like all birds are living things. That was the nested hierarchies of definitions things, right? So part of the definition of a bird is that it's alive. If it's not alive, it's a bird corpse or something like that. So how do you do that inference? How is it we're able to use these concepts to make inferences? That was one of the things in our nightmare scenario where you can't do categorization. One of the things you become unable to do is inferences like this. So I say, if that's a bird, it must be a living thing. Therefore, everything I know about living things applies to that thing as well. Well, Aristotle's thing about how nested definitions have to contain the inner definitions, that tells us how this works. So that's good. That's helpful. It also explains why we find concepts synonymous. So to take the classic philosopher's example, bachelor is supposed to mean just the exact same thing as unmarried male, right? Bachelor is supposed to be synonymous with. So anytime you have a sentence that contains the word bachelor, you should be able to substitute in unmarried male and have the same basic idea come across, right? The truth value of that sentence is supposed to be preserved. Well, how does that work? Aristotle's got a really good answer for that. Aristotle's answer is something like this. He says, look, your concept is a conjunctive list of features. Same list of features, same concept, right? If you got a bachelor concept and that comes with a list, you have an unmarried male concept, that comes with a list. If those are the same lists, same concept. Right? So we have a very easy way to talk about why ideas should be interchangeable. And it also, let me explain this last one in a little bit of detail. It explains our productivity via compositionality. So what is that? What am I talking about? Okay, let's talk about, unless there's questions about where we're at so far. Okay. So the compositionality, you could think of this as kind of like the Lego blocks model of concepts. Notice the following. Take a minute to appreciate this incredible fact about yourselves. You have this unbelievable power that you can understand sentences that you've never heard before. So, there are currently no hyper-intelligent squirrels mining for gems on Mars to defeat the electric eels on Venus. I'm willing to bet you've never heard that sentence before in your life, and you might ask yourself why I was saying that sentence, or what television programs I've been watching lately that would cause me to generate it. But you all, I hope, had a fine time putting it together, right? What you did was, so hyper-intelligent squirrel on Mars, you know what a squirrel is, you know what intelligence is, you know what the prefix hyper means, a lot of. So hyper-intelligent, lots of intelligence, hyper-intelligent squirrel, squirrel with lots of intelligence. You put these concepts together very, very quickly, very fluidly, right? That's compositionality. Using compositionality, you have this ability of productivity. That is to say, any one of you could generate an indefinite, you could continue producing sentences until you died of natural causes, right? There's no limit to the number of sentences that you could produce, and those sentences have structure that gives them unique meanings. This is one of the things that humans can do that, as far as we can tell, no other animals can do. The ability to be productive in this way, so you can teach a gorilla sign language, and they can use the symbols. They can convey meaning. They understand that a certain sign means a certain thing. What they're not as good at, it turns out, is putting those signs together into complex structures with new meanings, like hyper-intelligent squirrel on Mars. That's not a thing that they're nearly as good at. And if you don't learn language before you're about 7, you won't be good at that either. So if you miss a kind of crucial language development window, you don't get compositionality the way that you all have. I can tell that you've all learned language before you're 7 because you made it to U of T, second year university. Tell me if you're not, I would like to talk to you again, but anyway. So this is one of these, like, just savor this for a second. This incredible power that you have that no other organism on the earth has, productivity because of compositionality. And again, so this is a really important thing that we want to explain about our minds, right? We have this power. If your story about cognition doesn't entail that we have this power, your story's missing something really unique and precious about our minds. And Aristotle's theory of the classical theory of concepts helps us do this, right? Just in the way that nested hierarchy stuff helps us do this. So you know what the list of features for squirrel are, you know what that list is, you know what the list of things for intelligence is. You just put those lists together. Now you've got hyper-intelligent squirrel, or intelligent squirrel, and then you add hyper onto intelligent. So his theory is, because it's all built up out of these atomic feature lists, these features are like little atoms. Those atoms are like Lego blocks, and you can build those Lego blocks together into more complex structures. So great. Aristotle's looking pretty good. Why did we bother with that psychology stuff in the first place? Okay, so that's the classical theory of concepts. We can now shift to showing why it's not going to do the job for us. Unsurprising that a 2,500-year-old theory of concepts isn't going to quite cut it, but let's go through it anyway. All right, so let's talk a little bit about Wittgenstein. And this, I mean, I'm sure he's not the first person in history to have said this, but this notion that our concepts have necessary and sufficient conditions attached to them doesn't seem to work out very well. Much to the chagrin of philosophers who spent all of those intervening 2,500 years trying to find necessary and sufficient conditions for all the important concepts like knowledge and justice and beauty and truth and that kind of thing, right? And if you so we would be producing definitions, trying to produce the necessary and sufficient conditions for being something, and if somebody produced one counterexample, that would be like, that can't be the definition because definitions are crisp, right? They have these really crisp boundaries, right? Something is either in or out. So if you've got one counterexample, that ruins your theory. Wittgenstein was famous for being having one of the best smoldering looks of any philosopher in history. Look at that guy. He's just got this real gaze on him, doesn't he? So he was one of the most important philosophers, analytic philosophers of the 20th century. He had famous for having two basic phases in his career. His first phase was he wrote a book called the Tractatus Logico-Philosophicus whilst in the trenches of World War I. Like, he wrote the book in the trenches. And the book had some fairly lofty ambitions. When he was done it, he said, "There you go, I have finished philosophy. You can all go home. It's done, I finished it." We won't talk about the Tractatus too much. What we're really going to talk about is his second phase, where he kind of walked back his claim to have finished it all. You can tell because he wrote another book. And he started critiquing some of the ideas he'd relied upon in the first book. One of those critiques was the idea that concepts have necessary and sufficient conditions. So his most famous example is game. So think about this. Okay, so hands up. Anybody not know the word game or what it means? We're all pretty confident we can use this word. If I say, this chair is a game, you say, "No, Corey, that's a chair. That's not a game," right? If I say chess is a game, you all go, "Yeah, okay, yeah, sounds right." So we can all use the word game, right? Okay. So what are the necessary and sufficient conditions for something being a game? Right. Maybe some set of rules. What about kids playing like imagination games? Kids can play games where they kind of make up the rules as they go along. Yeah.
Sort of challenge or an end goal?
Challenge or a goal, perhaps. I think, again, kids' imagination games can be kind of like goalless. You're just kind of ambling through it. And I have games on my phone right now that present no challenge whatsoever. Their only goal is to keep my fingers moving while I'm listening to podcasts. So I think maybe those aren't necessary conditions either. Yeah.
I guess conventionally some people say it's pleasurable to a certain extent.
So pleasurable, I would refute that with a counterexample of Monopoly, which is commonly understood to be a game, but is neither fun nor pleasurable for anybody involved, as far as I can tell. I suppose you get a certain vicious kind of pleasure from having defeated your family. Yeah. So lots of things get called games. And even if you can come up with some necessary conditions, something that they all have in common, it's even harder to come up with a set of sufficient conditions. So things that they all have in common, and if it's got all of those things, then it counts as a game. Yeah. So, I mean, people say things like, it's got players, and in game theory, there are what are called zero-player games. They're things that just work on their own. So Conway's Game of Life, if you're familiar, is a zero-player game. It's really hard to come up with a set of necessary and sufficient conditions. And it's not just game, I would insist. My mom tells the story of spending hours in her university education trying to do this for chair. What are the necessary and sufficient conditions for something being a chair? Like, it's got legs? No, some stools are a kind of chair. Beanbag chairs are a kind of chair. You know, it's comfortable? No, there's lots of uncomfortable chairs. Like you can play these endless games, and I mean I'm using simple examples because yeah.
Sorry.
Oh, good.
For a game, could something like pastime be a condition?
What's a pastime?
Like
Oh.
a form of passing time.
Oh, yeah.
Something to keep you distracted. Like thinking about a chair.
Yeah.
You can see that as sort of a game because you're challenging your mind and you're passing time by thinking about it.
Okay. How about war games, where there's an extremely serious goal, and they're not just trying to entertain themselves; they're trying to train for bloody conflict, and they're all being evaluated by their superiors on how well they did at it. So nobody's particularly there to have fun or just to pass the time, but we call it a game anyway. Yeah.
So would that make war game a game?
Well, they call it a game. And so here's the thing. We can certainly stipulate a definition. What we can do is artificially draw boundaries. So if you're saying like, look, I'm a games company, here's what we mean by games. It's got to have this, this, and this condition. That's fine. That's a fine activity to do. Like you can say, look, I don't mean, by game, I mean this and not that. You can build yourself a definition. But what this game we've been playing is meant to show is that, you know, you all know this word and how to use it, or at least you didn't stick up your hand when I asked you if you didn't. But nonetheless, we as a group have been struggling to come up with a set of necessary and sufficient conditions. So what that suggests to me is that we don't, despite being competent with the language, we have the ability to use this word. And it's not to say that you can't use the word game wrong, right? You can use it for things. You can use it incorrectly. So there's content in the concept. We have a notion of game. We have this concept. But what we don't seem to have are clear, necessary, and sufficient conditions for it. And Wittgenstein's point in his later book called The Philosophical Investigations, one of the many strange and rambling points he makes, is that words just don't seem to act like this. Words just don't seem to have these neat, crisp boundaries that they draw in the world. That just doesn't seem to be the way we act. And if you would like further evidence for this, I would cite for you the history of philosophy, where, again, people have been, as a matter of professional passion, they've been trying to come up with necessary and sufficient conditions for extremely common and important words for millennia, and failing and failing and failing and failing. And Wittgenstein says, sorry guys, you were kind of wasting your time. You were looking for something that doesn't really exist. So don't ask what knowledge is really, as though if you just thought hard enough, you'll come up with a set of necessary and sufficient conditions, because that's just not how words work. Wittgenstein instead suggests that words are kind of, his term is family resemblances. So the idea is, I resemble my family, right? That is, you know, I've got ears like my father, and a chin like my mother, and I got eyes like my sister, and so on. But there's no one thing that we all share. There's no one feature that every single member of my family has. Nonetheless, there's a kind of continuous overlapping of features, right? So game is a family resemblance. There are some things that a bunch of games have. There are some weird games that are kind of outliers, war games or zero-player games. But there's a kind of, another image that he uses is a rope. You know, like a rope where, to make a rope, what you do is twist together a bunch of little fibers. The fibers are short. The fibers can be like a couple inches long. The rope is 12 feet long, so no fiber runs through the entire rope. But nonetheless, the rope holds together because these fibers are overlapping each other. This one overlaps this one overlaps this one overlaps this one. So there's a kind of unity. There's clearly a unity of the rope. There's a difference between a rope and a pile of fibers, right? But nonetheless, there's nothing continuous all the way through. And that's what Aristotle's notion of concepts expects from us. That's what it expects from concepts, is there's going to be an essence to the thing. There's going to be something that every single member has, a list of features that you can say, if you got this, you're a member. If you don't got this, you're out. And Wittgenstein's critique is just to point out to us, and mostly his argument is in the form of check it out and see. Try to think about whether you can come up with necessary and sufficient conditions for things. And he expects that you'll come back with the same result that he did, which is mostly not. I'd like to wind that back. So mostly not is a carefully chosen phrase. Remember the square. There are necessary and sufficient conditions for squares. There are necessary and sufficient conditions in logic, computer programming. Like, your concepts in computer programming are well defined. They do not do this weird family resemblance thing. They meet the classical definition of concepts perfectly. If you've got a programming language with a loop function in it, you can tell when something's a loop function and when it's not. There's some list of features that it has, and if it's got those features, that's the loop function, and if it doesn't, then it's not, right? So there are parts of the world in which the classical theory of concepts works beautifully. Math, geometry, logic, other formal languages. But these are distinguished formal languages from what are called natural languages. Natural languages are the languages we all speak all in our everyday lives. Formal languages are these kind of artificial constructs that we build for ourselves. So the common sense notion of concepts was developed with things like math and logic in mind. They make sense of math and logic. What they don't do is make sense of human language, the language that we all get through our lives with. And if our goal is to understand human level intelligence, then understanding just the formal languages isn't going to cut it. We need to understand natural languages as well. Okay. Good? Okay, let's do another critique. So there's more problems for the classical theory. All right, so here's some psychological evidence that it's not going to work. This is from the 80s from James Hampton. So he runs a series of experiments. Recall this, this stuff about how the classical theory predicts that if you've got a large category, then the definition of the small category is included in it. So he asks people the following. He says stuff like, are car seats chairs? People go, yeah, oh yeah, car seats are chairs. Cool, that works. Are chairs a kind of furniture? Oh yeah, chairs are kind of normal, perfectly good kind of furniture. Are car seats furniture? People go, not really. Some people said yes, but some people said no. And it's okay if your intuition goes towards car seats are furniture, that's fine. The problem for the classical theory is that it predicts that there should be perfect uniformity on this. Everybody should agree. If you answer yes to the first two questions, 100% of people should answer yes to the third question. Not just some or most. Everybody should agree, because car seats are kinds of chairs, chairs are kinds of furniture, therefore car seats have to be a kind of furniture. If theories get embedded in this hierarchical structure that we described earlier. Yeah? So this transitivity fails. When you ask people these questions, this transitivity fails, which is evidence against the classical theory of concepts. Yeah, so just all that. Yeah? Sure.
So like, I guess like for me, like relating it to, let's say, a swan and a sparrow.
Mm-hmm.
They're both types of birds. Both swans and sparrows have wings.
Yep.
Okay, that makes them classification of a bird. Car seats are chairs.
Yep.
And chairs are a category of furniture.
Yep.
But like furniture, I don't know, like car seats, it seems like chairs would be like the main, and then car seats, stools, you know, like bean bags. And car would be another category.
Oh, I
and
see.
Then car seats falls under car. So does like air freshener falls under car. And like furniture has its own, car has its own, and then those are two separate distinctions.
I see.
But
I see.
there happens to be like this form of similarity between a car seat, because you can sit on a chair, and a chair which is an actual seat.
Does that mean that you're denying that car seats are chairs?
No, I'm saying that car seats are chairs,
Uh-huh.
but they're chairs for a car, whereas furniture is not like connected to cars. Furniture is connected to not a car.
I mean, I think I think what you're trying to do is diagnose where Aristotle's gone wrong here, because if Aristotle's right, this should all follow, and you're trying to dig onto like, okay, what's going on, and basically it sounds like what you're saying is we've just got a whole bunch of other categories in the background operating on these categories. So the content of the category doesn't sort of sit. If it sounds like what you're saying is the content of category is not easily boiled down to just a list of features. Does that sound right? Because like, if it's just a list of features and Aristotle's thing should work, what you're suggesting is, look, we've got this whole other concept of car that has different connotations. Furniture, usually imagine it sitting still in a home or in your patio or whatever. But that's just a reason to doubt Aristotle. It's a good reason to doubt the classical. So it sounds like a decent diagnosis of what's going wrong with the classical theory. Yeah. Yeah. Sorry, I said another hand. Yeah. Okay. Okay. Good. Good. Yeah.
Well, why do chairs have to be contained in the category of furniture?
So you could just to be clear. So you could deny, like, it could be the case that you would deny one of these first two things.
But I would say that chairs are a kind of furniture. But
okay.
That doesn't necessarily mean that all chairs are furniture. It can overlap.
So.
Some chairs are furniture, some aren't.
But if chairs are a kind of furniture, that means that entails, at least for Aristotle, that entails all chairs are furniture.
Right. No, but does it? Because you can have, like, here's furniture. Chairs are here. Chairs are a kind of furniture, but some of that is not inside furniture.
I wish we had a blackboard here because I think I could draw. So you've got a Venn diagram with like circles there exist chairs that are furniture, but it's not the case that all chairs are furniture.
So some of that property
right.
that it would overlap, but some of them wouldn't.
Right. Yeah. So, okay. That's good. Is that worrying for this? So what we got here is, this is supposed to be a refutation of the classical theory of concepts. Does that help the classical theory of concepts?
Well, no, because there are critiques of it. But
okay. Well.
I don't like this critique.
Well, yeah, no, we'll deal with one critique at it. So does it worry this critique? So I guess the question is, so we'd have to go to the paper. I don't remember this paper in detail. We'd have to go to the paper and look at other examples to see if the same pattern of problems occurs. I really think that if you ask somebody the question, for Aristotle, if you ask, are chairs a kind of furniture? If they say yes to that, then what they're endorsing is all chairs are furniture. So you'd have to rephrase it. If you wanted to ask your question, you have to rephrase it to, do there exist chairs that count as furniture, or something like that? So like, not all people count as lawyers. Lawyers are people, but not all people are lawyers. So you'd have to do something like that. Yeah, we'd have to look. I think this is a decent critique. What we'd have to do is investigate the set of questions that he asked. It wasn't just the car chair thing. He asked a set of questions about embeddedness. Yeah, that's good. That's interesting. Yeah.
Doesn't this kind of stem up from a problem of not being able to put things in a circle? Like, we're not able to define what a chair is. So if we're not able to define what a chair is, aren't these two critiques kind of overlapping in that sense?
Yeah, they are. Yeah, I think that's right. So this is what this is supposed to be digging out, is, as a problem for classical theory, is that we just don't have what fails is the crispness of our definitions. The crispness of our definitions is what's supposed to make this transitivity work. And if the transitivity works, then like, that's evidence that we've got really nice boundaries around what's in the category and what's not. And if that fails, then transitivity is going to fail too. We're going to heap a little more misery on the classical theory, and then we'll move on to what's come after it. So just one more thing here. So another prediction of the classical theory, recall, was the following, that all members should be equally good members. That is, a square is a square is a square. There's no better squares or worse squares insofar as they are members of the category square. But really, that's not how people act when you ask them questions about this stuff. So there's been extensive psychological literature, we'll review some of it shortly, on people's ratings of how well something matches a category. So if you ask people to rate robins, how good of a bird they are, people go, oh yeah, robins, those are excellent birds. Those are as birdy as you get. Whereas if you ask people about penguins, they go, yeah, those are birds. They agree that they're birds. Nobody's like, well, very few people at least are like, I shouldn't say nobody. People say the most bizarre things on when you do surveys of people, around 4% will tell you that they believe that lizards from another dimension run the planet. So I should never say all people do X, because a certain percentage of people will always do something bizarre. Anyway, so you ask people, are penguins birds? They go, yeah. And then you ask them, how good are they as birds? And you say, not so much. They don't have, they don't have the things that I want birds to have. Like flight, for example. Penguins don't fly. So that's curious, right? If you're a classical theorist who believes that all members of a category are equally members of the category, that's evidence against your view. And they didn't just take people's word on it. So fortunately, self-reports are quite tricky. Getting people to report their own mental states is a worrying thing to do. For example, this is my favorite fact about self-reporting. If you ask in the same population, heterosexual men and heterosexual women, how many partners they've had, how many sexual partners they have, the men will report about 1.5 times as many as the women. And what do you know must be the case about those two averages? They have to be the same. The average number of partners for heterosexual men and women has to be the same in a population. That's just a mathematical fact. And the men are reporting 1.5 times more than the women.
I don't think you're counting the lizard rulers from other dimensions.
Perhaps not, perhaps not. So I don't know who's not reporting accurately in those questions. It's unclear because it's just a self-report. But anytime you see a self-reporting thing, I'll keep this little thing in mind. Okay, so yeah.
Could there be like a difference in what people consider? Like,
It could be, yeah.
Would that then be an issue of like how you define a particular term?
Right. So that's one of the deep issues with self-reporting, because you don't always know that the person you're asking knows what you're asking. So, or that they all think that you're asking the same thing. So we might have, because we don't have clearly defined concepts, people have different concepts of the thing that you're asking about. So that's when you're asking, and even if you carefully explain it, people's attention spans are short enough that if you just let me tell you as a teacher, you can carefully explain things to a group of people and like many will not get it the first pass through. So even if you carefully explain the concept, some of them won't be getting it. So this is, again, a problem with self-reporting. This is just a deep problem of psychology literature where self-reporting is an incredibly important thing. Fortunately, in this case, we have remember the stuff about multimodal evidence? So in this case, for future reference, it's okay if you come in that door. That's fine. In this case, we have another kind of evidence. So there's another kind of evidence that matches people's self-reports. So you do what's called a categorization task with people. You give them a bunch of things and ask them whether they're members of a category. So birds, and you say, is a penguin a bird? Or like, is a robin a bird? Yes. Is a cucumber a bird? No. Is the Eiffel Tower a bird? No. Is a penguin a bird? And they'll be a little bit slower to say yes to the penguin than they are to the robin. So, and the time delay, the lag that goes on between before answering things matches up very nicely with people's self-reports of how typical they think they are. So we're faster at categorizing typical things than atypical things. So we've got at least 2 independent lines of evidence pointing towards the same idea, which is that people don't find everything to be equally good instances of their categories. Yeah?
So does this suggest like a problem with theory, or is that a problem with people?
I think it's a problem with the theory. In this case, so this is broadly a psychological theory. Maybe I should ask a follow-up question here. How could this be a problem with people?
Because robins, like penguins, objectively speaking, are birds.
Yeah.
But subjectively speaking, I wouldn't see them as much birds as robins, just because they can't fly.
So so we just say like people are bad at categorization. Is that the thing?
Well, because penguins don't
Yeah.
according to what we think birds are.
Yeah.
So is that a problem with the theory, or is that just like our education?
I think that that's a problem with the theory. My tendency is because of what the theory is supposed to do, the theory is supposed to tell us about how we work. So that's the goal of the theory is to capture, and a good theory of cognition should not just reproduce our successes, it should reproduce our failures as well. Because that's the pattern that tells you that you've really gotten at how we're doing it. Yeah? So if you build a theory of cognition that gets it right every time, it's just objectively perfect, you can tell for sure that that's not how we're doing it, because we are far from perfect at reasoning, right? Yeah.
Couldn't it just be a problem of how fast people are recalling information?
So if it was only the time test, then that would be a reasonable interpretation, but we've also got the self-report test. So we've got two lines of evidence pointing at the same notion that people find things to be better or worse exemplars of a category. That's the argument given here why you shouldn't think that. Yeah.
But we still do binary categorization. We still say a penguin is a bird. And so since classical theory isn't based on similarity, does that even matter, because we're still doing the binary categorization?
Well, so we do the binary categorization in this case, but we also are willing to make differential judgments about the goodness of fit in the category. So it is a problem for the classical theory, because the classical theory predicts that every member should be equally good of fit. Like it should have equally. It's like citizenship. Like there's no, if you're either a citizen or you aren't. There's no like, well, you're sort of a citizen, right? Not yet, anyway. Fingers crossed, and hopefully keep this democracy thing going. So the classical theory predicts that there should be no differences in the judgments of people on how good a member is of its category. Whereas even if they're willing to, so given we are doing binary categorization here. We're saying, yeah, a penguin is a bird, but people are willing to make the judgment that it's not as much of a bird as a robin is. So the classical theory predicts we shouldn't have anything to say about that. It should be just a totally flat, there's no hierarchy of like birdiness in our minds, whereas people are willing to make those judgments, and then we have the second line of evidence about timing that suggests that there's something behind that other than just what people are saying about themselves. That's how this is supposed to be a problem. Okay, yeah.
Just going back to people are the problem.
People are definitely the problem. Let's be clear on this. Okay, yeah.
Fairly suggestible. So if you give them a survey and you say, like, are these birds, and you leave a blank section, is this more or less of a bird?
Yep.
People are going to put stuff there,
Yep.
most likely.
No, that's true.
Whereas if you give a survey that just says, is this a bird, yes or no, people are writing in the margins, penguin, bad bird. That's a little bit different.
Okay, that's fair. Okay, so that's fair. I would like to actually follow up on something that you said. Sorry, what's your name? Kyle. Something Kyle was saying about binary classification, because another problem with the classical theory is that we don't always do binary classification. We are very often willing to go, well, sort of. This is a very normal way of, so you think of the Sorites problem of when is a person bald? So if you take one hair off somebody's head, they don't go from being not bald to being bald, right? And then you repeat that problem, you repeat that over and over again. And there's a kind of like shading from not being bald into being bald. And of a given person, it's not always the case that if you ask somebody, is this person bald, they will go yes or no. They'll often go, kinda, right? So just the very existence of this broad category of judgments of saying, is this an X? And you go, sort of. And it's not that you don't have any opinion, it's that you think it's a fuzzy, it's a liminal member. It's a member kind of on the border of the category. And the reality is that we make that kind of judgment all the time. Like people make non-binary category judgments. We say, is a is a, blanking on examples. You know, is a car chair furniture? People go, sort of. That's what I said when I saw that example. I said, sort of. Is it furniture? Not yes completely, not no completely. Kind of. So that would be my reply. That even if people are being, and I do worry that how to understand people's self-reports against their timed reports. So we've got two lines of evidence converging on this, one of which you can write off by people being suggestible, one of which is not their conscious reaction, but just their unconscious reaction. So that worries me. The fact that we very often make non-binary categorization judgments also worries me about this. So like, we do it all the time. Is he your friend? Kinda. You know? Is that satisfying? No. Okay. Okay. So enough heaping misery on the classical theory. Okay, so, and just to clarify, what I've given you right now is not a proof that the classical theory is wrong. Again, I have in no sense proven to you that this is wrong in some deep way that can't be remediated, that couldn't be fixed up. What we're doing here, remember the very first lecture when we talked about plausibility, I'm trying to give you an argument that this is not plausible. There are enough lines of argument that sort of point against this that we might be motivated to look for something new. Not that I've given you the refutation of it for once and for all. Yeah? Okay, so let's move on to prototype theory. So, Eleanor Roche is a good scientist because she read philosophy. Specifically, she read Wittgenstein. That stuff that we were just talking about family resemblances and the failure of necessary and sufficient conditions. And she thought, hey, that's good stuff. I'll try to do some science about that. Specifically, I'll try to build a theory of concepts that takes this stuff into account, that doesn't rely on necessary and sufficient conditions, that doesn't rely on clear, crisp boundaries or clean transitivity of embeddedness. So, Roche says the following. A concept is a list of features weighted by their importance. And when we categorize, we ask ourselves, how many of the features does this object have? And how relevant are those features? And what this gives us is categorization by degrees. So when you ask yourself, is a penguin a bird? You go through your list of features you have under the category bird. You say, well, it's got wings and a beak, it lays eggs, and it flies. And you go, penguin, well, it's got wings, it's got a beak, lays eggs, doesn't fly. So what I'm going to make the judgment is, I'm going to make the judgment that penguins are mostly birds. They're bird-like. They're reasonably good exemplars of the category of bird, much more than a bear or a seashell or the Eiffel Tower, right? All of those are clearly non-birds, but a penguin is mostly a bird. All right. So this gives us something without crisp boundaries. So here are 5 features of the prototype theory. Categories have what's called a prototypical structure. So there's a kind of core that's the prototype. It's the, not prototype in the sense of it's the first one off the line. It's the prototype in the sense that it's the like, I don't know how to represent a prototype. I've given you this very rough sketch of a bird. That's my internal image of a prototype. But like, you imagine when you're thinking about apples, you imagine the most typical apple. And that's kind of your central image of what the core of the category is. And then there's a kind of halo around that core where things resemble it more or less. So there's no strict line. There's no necessary and sufficient conditions. That is, you can miss, of any of the features in that list, you can miss one or two and still be in the category, right? In the classical theory, if you miss one of the necessary features, you're out. Whereas in the prototype theory, there's no feature that you can fail to have but still be in the category. Now, if you miss enough of the features, right? If you say birds have wings and a beak and lay eggs and fly, and you have none of those things, then you're not a bird, right? So if you miss all of the features, you're obviously not in the category. If you have all of the features, you're obviously in the category, but you're allowed to miss a couple of them. Think of this in terms of, like, is there any necessary features for being a human? This is something that we're going to confront as the machines slowly impinge on our humanity. We slowly start replacing parts of us with machine parts. Like, is there anything that you consider absolutely necessary for being a human? Well, you got arms and legs. No, there's humans without arms and legs. Well, you got rationality. No, there's humans without rationality. Babies, for example, right? Babies are humans, babies don't have rationality. Like anything that you can think of that's constitutive of humanity, you can imagine just missing that one thing and still being human, I propose. If you can think of a thing, then you've got something really good to pitch to the AI ethics people, because they would love to know what's the essentially human properties of us. Yeah. Some people don't have emotions. Yeah.
Why not a genetic code?
Because you can alter the genetic code of a human, I would suggest.
Yeah, but it would still be similar enough, or else they wouldn't be human. You'd be altering it enough to make them not human.
So imagine every cell in my body had the genetic code stripped out of it, and all I had was a bunch of little nanobots that produced the relevant proteins in the relevant amounts. Am I now no longer a human? Arguably, yeah. Okay, so human is the emotionally fraught one, so just to get you into this. So, but, all right. So, boundaries between categories are unclear, so arguably is the right answer for a lot of questions. That is, on this theory of concepts, saying something is arguably a member of the category, saying it's unclear whether it falls into the category or not, can be not just a fact of your ignorance, but the truth of the situation. Really, it's the case that it's just unclear whether it's a member of the category or not. Instances of similarity can be judged on typicality. So how typical is the feature? How typical are the properties that you're picking out? And category membership is determined by, I'm sorry to say, similarity to the prototype. So that might be an issue going forward. Yeah?
Isn't context important? Because, like, let's say we ask, like, a group of 1,000 people, are airplanes birds? Right?
Uh-huh.
I mean, airplanes have wings. We have to give them a little bit.
They fly. Yeah.
Airplanes don't lay eggs. You could then ask if people consider ostriches birds.
Yep.
And I think, depending on the answer, like, I think.
They're less happy with ostriches as birds, yeah.
Yeah. But would they be less happy than airplanes? Probably not.
No, yeah, probably. They probably like airplanes less. So we're gonna see. So it's good. You're jumping ahead. So we're gonna see how context is important. And actually, that's going to be one of the worries for prototype theory, is that it doesn't give us enough machinery to talk about how context is important. So
I think it also, I mean, just to add something to it, I think
Yeah.
it also has something to do with, like, words themselves are attempts to describe things, right? And so I think context is also important in that as well.
hugely important, yeah.
Because words aren't, by definition, specifically attempting to describe a specific thing. They're describing usually like a concept.
So let me just let me just pick up on the word context for a second, because you're gonna be tempted throughout this to explain things in terms of the context, and that's probably right and true. So one of the amazing things about humans, one of the things that we can do that no other, that at least machines can do, I think animals can do this, we can take context into account. But when you say context, what exactly are you saying?
So I would say that it's, so if we use the example of the word game,
Yeah.
right? If all you could do when you're communicating with somebody else is use the word game,
Yeah.
I think your ability to effectively convey your meaning and transport to somebody else would be like severely limited.
Practically, no, yeah.
So context would be essentially when you construct a sentence, you're giving most of the words that you use are instructions on how the keyword is to be understood.
Okay, so there's context within the sentence. There's also context of the sentence. And okay, so take the literal meaning of the word context. Context, outside of the text. Context is everything that's in the background. Everything that's in the background. So when you say, I'm gonna understand your sentences based on context, what I'm taking into account are things like our past history, the day of the week, the socioeconomic context, our point in history. I'm taking into account your facial expression and your body language. I'm taking into account the temperature in the room. I'm taking into account, like, literally everything that's outside of the given text is part of the context. But that's a really large set of factors, right? The context is like a practically unlimited number of facts about everything that surrounds the text. So when you say that we're taking into account context, what you're pointing out is this miraculous capacity that we have to integrate all of that into how we interpret the world in our language. So when you have a sentence, you interpret it in terms of context. What that means is that you're like bringing the whole rest of the universe to bear on understanding that little sentence, which is like an amazing thing that we do. It's an incredible power. We just have no idea how to explain how we do it. So that is going to be part of the problem for prototype theory, because we do make judgments based on context. And this similarity thing is one of your hints that this is going to be a judgment about relevance or salience. So what you do is you pick out the relevant parts of the context when you're interpreting what somebody's saying, or you're interpreting the meaning of a term, or you're interpreting what gets to count in a category or isn't in a category. You're taking context into account, which really means what you're doing is taking the relevant parts of the context into account, which really means that what you're doing is being an intelligent agent. So context is I don't think that you were doing this, but I think a lot of people are very tempted by context as an explanatory device. You weren't using it as an explanatory device, but people do this very often. I was tempted by this when I encountered this material. We say, well, what you do is you just take the context and add it on there. But what the move that you've made there is just to say, what I'm going to add on is the rest of the universe, and then just build that into my explanation, which is tricky. Hi, yeah.
Is that definition of prototype supposed to be conceptual, or is it like more literal?
Sorry, so we're supposed to be defining, what do you mean by the conceptual versus literal?
Views kind of based on like some, so it seems to like a central kind of image of a certain thing,
Mm-hmm.
But like that in itself can have like
I see what you mean. Yeah, so it could be that you've never seen the prototype that you're thinking of. Yeah, so the prototype, in that, I think I get what you mean now, and it's like the view is very much that you've got a conceptual kind of like median. So you imagine you've got a prototype for Apple. Maybe you've never seen the most prototypical, in your head, you've never seen the most prototypical Apple. You've seen ones that are this color and that color and this color and that color. You've never seen the one that's right in the middle of them, but the one in the middle is your prototype. So you've never seen the prototypical bird, you've only seen specific birds. And what you're doing is putting them together, amalgamating them into the most typical, or the one that they're all most similar to, something like that. Yeah. Yeah.
Doesn't this fall into the same issues with resemblance theory, because you need to take into account salience, which is an intelligent process, like creating a prototype is something that is like more basic than categorization?
Yeah, that's to preview where we're going to go for the rest of this lecture. That's pretty much what's going to happen. But nonetheless, when you open a psychology textbook and they tell you about how concepts work, that's what you're going to find to this day. This is still a current hot theory of how concepts work, conceptual structure, and it's got some pretty deep problems, and amongst them the stuff about prototypes or about salience. But it does some good stuff too. Let's say some good things about let's say some nice things about prototypes quickly before we start tearing them apart. So prototype theory explains why we can't produce definitions in Aristotle's sense of definition. Right? We did this stuff with game. I tried to show you that you don't have a definition in your head in the sense of necessary and sufficient conditions for game. Prototype theory is fine with that. Prototype theory says, well, you've got a prototype of games. That prototype might have a bunch of features like having two players who are having fun. They're passing the time. It's enjoyable for them. Those are the kind of things that their rules, their structure. Those are the prototypical features of games. And then this activity that I did with you of like, haha, I can think of one thing that's a game that doesn't have that, just really isn't relevant, right? Because for prototype theory, it's a list of features. It's still a list of features, but no one of those features is necessary. So if we say games have players, and I go, yeah, well, not this one game, that's fine because it's just not a prototypical game. It's a kind of weird game that's off to the edges of the game concept. So you have a game concept, it's a list of features, some of which are more important than others. And if you're missing one or the other of them, like being fun or having players, that's fine for prototype theory. You still got a concept. It's not a defeat of the prototype to have a thing that's in the category but missing one of the features. It's got this kind of built-in robustness. So that's nice. It explains why members are not all equally good instances of the category, right? Because we allow for kind of like being further or nearer to the prototype. When we talk about war games, it's not a very good game. It's not a fun game at all, right? So a war game is a weird kind of game. It doesn't fit nicely into the category games. Ostriches are birds, but they're really weird birds because they don't fly, right? So ostriches are bad birds in some sense. They're not bad, they're fine. But they're not your typical bird, they're not prototypical, and prototype theory has a perfectly good time with it, whereas classical theory choked on this, right? Classical theory says every member of a category is equally representative. Prototype theory says, nah, you don't need that. The more of the relevant features you have, and the more relevant features they are, the more you're like the prototype, and therefore the more central you are in the category. So that's good. Helpful, right? And it finally explains why categorization is not transitive, right? So all birds fly, penguins are birds, therefore penguins fly. That doesn't work, right? Because we did this necessary, and the first line of that reasoning involved all birds fly. Whereas prototype theory would say something like most birds fly, or generally birds fly, right? You say typically birds fly. Penguins are birds. Typically birds fly, and penguins are birds does not entail, therefore penguins fly. If you knew nothing about penguins, you might be able to infer probably they fly. But that's not getting that wrong, right? So this intransitivity of categorization follows nicely from prototype theory rather than being a problem for it. Good. So we all love prototype theory now. Yay. It really is so I'm going to present problems for this, but it really is a live research program right now. This is not a thing that psychology's given up on back in the 70s. People are still working on prototype theory as a possible way of thinking about this stuff. I'm going to present problems for it, but again, the problems I'm going to present are not like, I do not mean this to be, therefore, prototype theory is irredeemable and cannot be fixed up. That's not what I'm trying to show you right now. We're trying to engage in cognitive science. We're trying to engage in the back and forth of critical thinking, digging under our assumptions, working out what's problematic, and then trying to move forward and come up with something better. Yeah?
Yeah. How is prototype theory different from resemblance theory? Isn't it just replacing concept with prototype? Sounds pretty similar.
They're pretty similar. They're pretty similar. Yep. Yep. One's a theory of concepts and one's a theory of categorization. Ah. Huh? Okay. Okay. Yeah, they're very similar. You're right. They're very similar. Okay. Okay. So problems for prototype theory. How do you produce prototypes in the first place? So a prototype, are we clear on what a prototype is? So a prototype has got only the following structure. It's a list of things with relevance in them. Okay. So how do you produce them in the first place? How do you decide to gather a bunch of things together into a category? And the theory really just doesn't tell us that. The theory is of conceptual structure, not of the origins of conceptual structure. How is it that you work out that a whole bunch of things that share some properties should belong together in a category? It's just not spelled out in the theory. The prototype theory itself doesn't tell us how that happens. Now, you could give an account, but here's the problem. Remember the stuff from resemblance theory of categorization, where part of what makes two things similar to each other for us is that we have a category that we apply to them, right? Like trees can look radically different from each other. Some are like this tall and have little spiky things. Some are 40 feet tall and have broad leafy things. But we nonetheless categorize them together as trees despite their visual dissimilarity because we have a concept of tree. This was the argument that I was making to you, that categorization drives similarity judgments just as much as similarity judgments drive categorization. So if that's the case, then we can't just look into the world and say, there's a cluster of features all hanging together, right, out there in the world, because the world doesn't cluster. The world doesn't come tagged as being categorized. The world is just a bunch of features roaming around. We impose order on it. We impose similarity judgments on it by having the categories, at least partly, not completely, but at least partly. So there's just this, and again, it's not that this is an insolvable problem, but it is an open question in this stuff. Where do these prototypes come from? How do we get them in the first place? We might come with some built in. I think that's a reasonable thing to think, that you've got some things built in. Babies seem to be able to do a fair bit. And it's hard to imagine how you get learning going without at least something being built in. But you certainly can't explain the origin of all of our concepts like that. It's fairly clear that we don't come built in with the idea of bird, right? Yeah? Okay. Okay, another thing. Typicality gradients. So here's how the theory tried to work. So prototype theory tried to formalize similarity judgments in terms of typicality gradients. That is, collections of measurements of how typical people found instances of a category. So you'd get some typically undergraduates looking to get extra credit on their Psych 100 class, and you'd put them in a basement and you ask them weird questions like, how typical is a penguin as a bird? How typical is a robin? How typical is a blue jay? How typical is an ostrich? So you would collect these typicality ratings, and these ratings would be built into typicality gradients. And then you would try to reverse engineer the structure of the prototype from these typicality gradients, right? So these judgments are data points, and those data points are you try to put them together into a map of the structure of people's concepts. Right? So this is how the prototype theory goes from just an abstract theory to try to investigate people's actual conceptual structure. Sounds good, right? Aha. Okay. So, but what they found was people have unstable typicality gradients. So this is where the context stuff comes in. So this is where context is actually important to defining people's typicality gradients. Again, these typicality gradients are supposed to be maps of the structure of a concept, right? You have a concept, beverage. That concept is supposed to be a stable list with relatively stable relevance weightings for each of the members of that list. But what people found was those ratings are not stable across context. So if you ask somebody, what's a typical beverage? They say things like water. But if you ask them, what's a typical beverage for a secretary on her break, his break, I suppose it was 1983, they would have said her break, but they'll tell you tea. Now tea is a much more typical beverage than water. If you ask somebody what's a typical beverage for a trucker, they'll tell you, weirdly they say milk. I don't think that's true, but maybe it was in 1983. Anyway, so if you ask people about different contexts, what they'll do is give you different typicality gradients, right? So what that means is that the structure of these concepts, so they're trying to measure the structure of people's concepts, and what they found was they don't have a stable structure. Typicality gradients are supposed to tell you about how the prototype has got, the internal structure of the prototype, and they found that just by priming people to think about different contexts, they would have different typicality judgments. That's worrying for this theory. Because, again, think about the machinery that they have available to explain things. A prototype is not a dynamic typicality gradient generating program. That's what you want to think of it as. You want to think of it as this flexible, changing dynamic thing. And that's probably a reasonable way of thinking about this. But that's not what prototype theory tells us concepts are. Prototype theory tells us concepts are lists. It's just a list. You could put it in an Excel spreadsheet. Yeah? It's just a list. So that list does not tell you what to do when a new context comes along. Right? What's a typical beverage for a kid coming home from school? What's a typical beverage for going to bed at night? What's a typical beverage for studying? What's a typical beverage for visiting your mom? I bet you have judgments of all of those things, right? I bet you had something flash behind your eyes to say, yeah, here's what a typical beverage would be for me. Now, what we were trying to investigate was the structure of this concept. And I hope you agree that you have a beverage concept, right? Everybody gets what a beverage is. Like, nobody's mystified by this. Now that I'm saying this, you're like, do I know what a beverage is? But you do. You have a beverage concept. There's no problem there. But what happens is, as soon as you add contexts in, you get different typicality gradients. You have unstable typicality gradients. You're perfectly able, you have this ability to update your typicality gradients based on context. And I don't know if it had ever occurred to you to wonder what a typical beverage for visiting your mom on a holiday is, right? I don't know if that's a concept that had ever crossed your mind before, but you're able to do it. So was that somehow built into the beverage concept originally? That's difficult because then you kind of need an infinite set of different beverage concepts. And that's too much for us. Like you can't have again, it's worrying when these objects proliferate into like unbelievably long lists of things, because again, we're trying to fit these into our little bodged together meat computers. So it's worrying if you need an infinite beverage, a list of infinite sort of different typicality gradients for each possible context. It looks like we're able to generate them as necessary, right? It looks like we're able to update our typicality gradients according to context. So you can't have these lists built in. This makes it look like it's very difficult to explain. Let me try to dial it back here. It's very difficult to explain how we would translate this into just a list of features weighted by relevance. No? It's much more dynamic than just a list. Yeah?
Would this ability be sort of related to how we generate like ad hoc categories?
I think it is. Yes, I think it is. So we're able to flexibly, dynamically, and appropriately generate ad hoc categories. This we're able to flexibly, appropriately, and dynamically generate new typicality gradients for things that we'd never thought of before. What's a typical beverage for trying to convince a post-apocalyptic warlord to be your friend?
Vodka.
Yeah, that's perfect. Right away. And you probably never thought of that before, but we're able to do it on the fly. Like you certainly didn't think through all of the times that you tried to convince a post-apocalyptic warlord to be your friend. That's probably not that you don't have a rich data set to draw on, unless you do, and you have a way more interesting life than I think you do. But so another worry. Do you want to take I don't have loads and loads more. Do you want to power through or take a break? Hands up for power through. Hands up for take a break. Okay. Okay. You guys can tune out and watch the YouTube video. Sorry. Yeah, we're gonna power through. Okay. Okay. So is the issue here clear? It's just kind of all I'm trying to point out is the poverty of the theoretical structure relative to the dynamic qualities of human judgments here, right? You do this really flexible, dynamic, context-sensitive thing. The theory just provides us with a static list of stuff. And that's unsatisfying. Not to say it couldn't be patched up, it's just worrying. Okay, here's another thing. The failure of compositionality. So, remember that thing about compositionality, the Lego block thing that we're able to do with our concepts and ideas? Impressive, important to explain. Prototype theory, unfortunately, doesn't have the resources to explain it. So, Medine, Douglas, and Shobin did this fun little experiment where they asked people soliciting typicality gradients. So they asked people, how typical are small spoons versus large spoons? What do you think is more typical, small spoons or large spoons? People go, small spoons. Mostly people thought small spoons are more typical. Okay, good. What's more typical, wooden spoons or metal spoons? Metal spoons. People thought metal spoons were more typical. So what you should expect is for small metal spoons to be the most typical and large wooden spoons to be the least typical. But that's not what people said. So the same group that made these judgments said the following. They found small metal spoons to be the most typical, then large metal spoons, and then large metal spoons and small wooden spoons to be the less typical of the category spoons. So yeah, the most typical is small metal, and then second most, large wooden. Large wooden. Like you'd stir a pot of soup with a large wooden spoon.
Sorry, you said large metal the second time.
Oh, sorry, I said large metal. Sorry. Okay, yeah, my mistake. I should have made another slide. Okay, so they liked small metal, large wooden, and then small wooden and large metal were less typical. Now, the only machinery that prototype theory has to work with when we're combining concepts like small and wooden are just summing up the feature lists. So to come up with a concept of small metal spoon, you should take your concept of small spoon and metal spoon and just add them up. That's all that the theory has available to explain and understand this stuff. Which is not enough, unfortunately, because people don't make judgments that are just the linear sum of the two concepts. They don't just mush the concepts together. The combination seems to be nonlinear, right? When you take two concepts and put them together, you don't just get the linear sum, the adding up of the two concepts. You can get something that's quite different than either of the original concepts, or at least the typicality gradients aren't a linear sum. Yeah? So that's what this experiment is meant to show. Okay? So again, the problem is the theory is fairly, like, the apparatus of the theory just doesn't match the complexity of what we're doing. Okay with that? Okay. I get the feeling that we're trying to get through it now. We're just trying to survive this. Okay. Unless you're in the first couple of rows, you probably can't read it. But here's another one. So here's a very interesting experiment where they're very directly testing the prototype theory of mind. They're taking aim at it in a very like almost destructive way. But that's good science, right? So we know some concepts have typicality gradients, that they're like roughly, there's things that there are people who are bald and people who are not bald and people who are kind of bald. I'm kind of balding, like it's not where my hairline used to be, right? So there are some concepts that are like that. There are other concepts like square or odd number where there shouldn't be a typicality gradient. We know the structure of those concepts, right? We know how those concepts have internal structures. We know how they work. So you shouldn't see typicality gradients in those. So what these people did was try to solicit typicality gradients for things that shouldn't have typicality gradients. And what they found was that, yeah, people produce these things. So on the left-hand side, you have prototype categories that they think are reasonable to think that there are typicality gradients for. Like how typical, so this is the category and these are the instances. So how typical is a car as a vehicle? And the lower the number, the more typical it is. So cars, 1, oh yeah, that's a vehicle, that's a perfect vehicle. Boat, 3.3, that's sort of a vehicle. Skis, 5.6, that's not much of a vehicle. Skis aren't really vehicles. They are untypical as vehicles. So, okay, so this is the standard thing. This is how people would generate these typicality gradients. This is how they were trying, there's a very, very standard methodology in this literature to try to measure the structure of prototypes. The right-hand side here are well-defined categories. So, plane geometry figure. How typical is a square as a plane geometry figure? People say 1.3. An ellipse is 3.4. They're exactly equally plane geometry figures. How about this one? Even number. Even number. How typical is 4 as an even number? 1.1, very typical, highly typical even number. How about 34? Nah, 3.4. 3.4, that's not really it's only sort of an even number. That's worrying, right? It's worrying that people are generating these typicality gradients. Like, so 447 is a 3.7 on typicality as odd number. That's about as typical as a asparagus is as a vegetable. What? Yeah.
I don't know, this seems to support that we have these well-defined categories, because without exception, the well-defined categories have a lower, least typical thing than the prototype categories, right?
So So if
you're forcing people to say more or less typical, and then without
No.
exception, they're saying that the well-defined ones are sort of closer to the
No, because, so square is 1.3 typical of, and the lower the number, the more typical.
Right.
Square as a plane geometry figure is a 1.3. Car as a vehicle is 1.0. So cars are more typical vehicles than squares are as plane geometry figures.
Squares are also 1.5, which is interesting.
Yeah, there's a second column there that I don't really understand. I don't know what that is, but.
I was just thinking at the extreme end, like
Yeah.
the worst plane geometry figure is an ellipse, which is only a 3.4, whereas the worst vehicle is an excavator, which is 6.2. So you get further away.
It's interesting, but there should be one. These should all be, all of these well-defined categories should be one all the way down. Because we know that, like really like 18 is less of an even number than 4. That shouldn't be at all. That should be, they should all be exactly as typical as each other because we know what the structure of even number and odd number is. Sorry, I saw his hand first.
How do the numbers come, like how do they measure?
So
How do they get people to measure? What's the method?
this is what they do. I mean, so this is the same, what they're doing is they're using the same methodology as the broad literature researching prototypes, and they're just asking people, say, okay, so given the category vehicle, how typical is a car? How typical is a boat? How typical is a scooter? Yeah, they're asking people to produce a number. Yeah, on a scale of 1 to 7 or something like that, produce me a number. Now, you might think that that's a bad methodology. You might think that it's a worrying as a methodology. But what they've done is very clever. It's as if they've taken the methodology that they're trying to poke holes in the prototype theory. And so what they did was take the very standard methodology being used to research prototypes and then turn it to a use that they weren't supposed to turn it to. Right? So they were able to, this half of the chart is just to show we know how to do your research on prototypes. We know how to, we can produce typicality gradients like you produce. And then we ask people about even numbers and odd numbers, and we got these weird results. And you shouldn't get any variation here, given how these, like especially, like plane geometry figure, I can see maybe people get confused, but everybody here knows what an even number and an odd number is, right? Right? Yeah.
Do you think that if we redid this like study in today's generation and era, we'd end up getting different results? Because that's from 1983, and I don't know, it's just my personal belief that like if you're doing a study on millennials or even our age group, you're not going to have such a huge variance between like the even number of 4 and 106. Like it would either be 1.1 throughout the whole thing, or like 1.1 to 1.2, which shouldn't even happen again. But I mean, like, I feel like if you redid this study, people are more aware of a lot of different concepts now over what they used to be in 1983, whether they're studying pattern assessment.
Is the idea that people are getting smarter? I think that's true though, by the way.
Like not only smarter, but like more aware of different fields that perhaps they weren't able to access.
Maybe, yeah. It's interesting. And there's problems with reproducibility in psychology. So there is I think that's a very good question of like how reproducible this is. Yeah. 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 So that's a good point. And the cleverness of this experiment is that any objection that you make to their methodology is also an objection to the thing that they're criticizing. So if you want to say like, look, you're not really investigating the structure of the concept vehicle by asking how typical car is, because all you're really measuring is how often do people see cars, rather than like what's the conceptual structure of vehicle. That could be a valid criticism. That could be a solid criticism against prototype theory. But all these people are going to say is, yeah, good point. It's a good point. That's a weakness in the methodology of studying typicality gradients. So we've got serious questions. I think you're both raising serious questions about the kind of methods that they were using to investigate conceptual structure. Like, are you really studying the structure of concepts, or are you studying a whole bunch of other things that could be confounded in with it? And these particular researchers would probably say, yeah, that's a deep problem. That's a serious problem for trying to use this as a tool for understanding concepts. Yeah.
But can't you like not separate how often you experience something from the prototype? Because isn't that how we generate them, presumably? Like if you ask someone in the 18th century about vehicles, they probably put like, if you explain what a car is, they probably put it like a 5 or a 6. But if you ask them like horse is a vehicle, they probably put it a lot lower than we do these days.
Right. Right. So they would say a horse is a typical vehicle, whereas a car would be quite odd. Did they have cars? Well, I don't remember what year you said.
18th century.
18th century, yeah, they didn't have cars yet. So, yeah. Unclear. To me, it's unclear. I don't remember what the instructions, I'd have to go back to read this paper again. I don't remember what instructions they gave them, so they might have specifically said to them, please try to separate out how often you see something from how much it's part of the concept. And then it's unclear to me, even if they've done that, how much people are able to follow those instructions. So we're getting, I think we're in the position where like the mind is doing a whole bunch of things all at once, and we're not always able to separate them all out. And part of the problem of doing experiments on the mind is we can't separate these things out. Like they all get mixed together. I see another hand. Yeah.
I think it also matters what like order they ask them in, because when someone asks you like how typical a car is to a vehicle, then you say yeah, it's pretty typical. But then as they go down the list, I guess for from the cars, you can like subconsciously compare it to what a car is.
I believe that they would have randomized the order. I believe they randomized the order. That's the kind of thing that you can actually control. That's the kind of thing you can actually control for in a psych experiment. So you just give them random orders because they're well aware of priming effects.
And to build up on what she said, I think.
Yeah.
I think this is more like a test of familiarity. So like when someone asks like, how typical is this number to an even number, then you just think what kind of question is that? And then you think yeah, pretty typical, and then when it's 106, you don't see that very much.
Yeah. Yeah, so I think that's quite possible. So this study doesn't show us why people are generating these they're generating typicality gradients where they shouldn't be. It doesn't tell us why they're doing that. It just shows us that they are, and it's supposed to be worrying for us in terms of the normal use of this stuff and studying. Yeah.
Might it have something to do with like just the system itself? If you're told to rate typicality, you feel like you have to have the most and you have to have the least typical. Therefore, you're going to start rating things.
Yeah, yeah. Another serious problem with, and I think you kind of said something like this. People are just going to produce numbers. You tell them to produce a number. You leave a blank for the number. People are going to generate numbers, and who knows what they're going to, on the basis of which they're going to generate that number. So these are all deep worries for using this paradigm for dealing with conceptual structure, I think. Yeah.
In the interest of like looking at prototype categories as like a means of understanding like the core aspect of like cognition. Isn't it hard to separate like a prototype category from like the act of like remembering? Like memory seems to be really important to like you need to remember that like what a vehicle is and all the instances of a vehicle for you to generate, I guess like a comparative feeling of, a scooter versus a car.
Good. So this is an argument for categorization not being a basic cognitive process. So you need memory to do categorization. Therefore, you need an analysis of memory as much as you need an analysis of cognition or categorization. Is that about right?
Yeah.
Yeah. Yeah. Another serious worry. Okay, we've been too long without a break, so let's push on. I hear the shifting. I've only got one other thing to tell you. So again, I don't watch movies that last 3 hours, so I know that it's intense to try to follow this stuff for too long. Okay. I did see Endgame. Yeah. Yeah. That's an exception. That's a okay. So one last thing that prototype theory predicts and that we do not find is that we should have what's called linear separability. Concepts should be linearly separable, and what that means is literally that you can draw a line between them. So let's suppose we got Suppose we're just categorizing according to 2 features. And we've got feature X on this axis, feature Y on this axis. Prototype theory tells us, you know, because all it can do is sum up the weights of a list of things. That's all the machinery that prototype theory is giving us. That means that if you're separating things into 2 categories, you should be able to literally draw a line between them, right? So here's my example. So suppose that this is not an image from science. This is me and Google image search. So this reflects no science whatsoever. Just to be clear, it's not a real thing, just for the purposes of examples. But imagine that we separate fruits and vegetables according to roundness and shininess, right? Suppose those are the 2 features that we separate them according to. So the less shiny it is, the more vegetable-y it is. The more shiny, the more fruity. The rounder, the more fruity. The less round, the more vegetable-y. Okay. So prototype theory says if this is how we're doing it, if this is how, so if we're using these, I'm imagining we've got very simple little prototypes. They've only got 2 features in them. But you should be able to draw a line between the 2 categories. And I've carefully constructed this image such that you can't do that here. There's no line that you can draw that would carve off the fruits from the vegetables. And I mean, this is a hilarious bodged together thing, but in actual fact, people are quite capable of learning categories that are not linearly separable from this. You can draw a curved line between the fruits and vegetables here. You could draw a curvy line, but prototype theory doesn't, because again, it's just a linear summation. All we can do is adding up. And adding up can only support linear separability. So what we're able to do is learn categories that are not linearly separable. And we'll see this once again. We'll see this much later in the AI research. So some artificial intelligence programs can learn non-linearly separable categories. We can do it for sure, but prototype theory predicts that we should only be able to handle the linearly separable ones. So the linear separability is something that seems to be required by the theory, but we don't have to be able to do it. Okay, let's call it a day. We'll come back and do one more day on categorization, and we'll move on to memory.